Today I wanted to talk about why 4K. So no, it's not like the big next millennium bug, so nobody has to worry. You don't have to go get your like how I survived the why 4K disaster. But it actually is this pretty significant problem that a lot of people are seeing, and that issue is the growth of the sector size from 512 bytes to 4Ks on commodity drives and even enterprise drives. So if we just kind of look a little bit at the history of how we got here, how we got to 4K sector sizes, it all kind of stemmed back to 1998 when IBM published a paper indicating that 512 bytes had kind of reached its lifespan and the industry needed to change. From there, the industry actually created a committee to start researching whether 4K sectors were viable. And at the same time, ZFS started its implementation. So around the same time when the industry is looking at 4K sectors for the future, ZFS is coming out of the ground. And one of the things that ZFS started with was the ability to have block sizes that we would use to store that varied everywhere from 512 bytes all the way to 128K. Around 2005, the 512 byte emulation mode for emerging drives was named, and later it was actually named to the advanced format 512E. Some of you may be familiar with that. And then shortly thereafter, ZFS actually added support for large sector sizes. Now, again, I mentioned that we already had logic that allowed you to have multiple record sizes or multiple block sizes. This was adding some additional code into ZFS that would be able to detect whether or not you were using large sector size devices and then allocate things appropriately. Eventually in 2011, all manufacturers were supposed to start shipping what are known as AF512E drives. Some of you have probably had experience today. How many people have 4K drives in their implementation? Okay, cool. So like I said, there's actually two flavors of the advanced format drives. What people are seeing today are known as the AF512E devices. These provide an emulation layer. I'll talk a little bit more about it. And then supposedly in 2012, we're supposed to start seeing the first shipments of the AF4KN, the native 4K sector size devices. I did some research trying to find out if anybody had any in hand, and so far I've come up with a 0 number. Anybody using native 4K sector drives? No. So 2012, maybe?
So just a question, is native mean it only does I/O? So a lot of the drives will report a physical and a logical block device. Some of them lie and get it wrong, and so you have to blacklist or whitelist those. But a lot of the newer ones right now report a physical of 4K and a logical of 512. Is native?
So native is 4K only, no emulation mode at all.
And so any attempts to do the old I/O, LDA 48 or whatever?
Correct.
Okay.
So the whole idea behind the AF512E was to kind of provide that gap between transitioning from 512 byte addressing to 4K sector sizes. It provides this emulation mode that effectively does 8 512 bytes into one physical 4K sector on the drive. The idea behind this is that anybody who's actually using some older software, whether it's Windows XP, continues to work. Nobody has to do anything on the background. It all seems like it would work just fine. What's interesting is when you start thinking about and you go back and read some of the literature, this was actually an excerpt from the original 1998 paper. And there's this interesting little comment that says, hey, we want to continue doing the simulation mode, but it might actually not perform as well as a native 512 byte block, which is great. It's like, we really want to have this implementation that takes us to the future, but we might have a huge performance regression somewhere in the middle. But the reality is, hey, ZFS can handle record sizes and is capable of handling sector sizes that span to larger blocks. So ZFS should be able to handle 4K sectors without a problem and continue to work. Unfortunately, there's actually some real significant problems in the 4K world. As was mentioned earlier, the drives lie. AF512E is supposed to provide a mechanism where it reports a logical sector size as well as a physical sector size. ZFS and Illumos, and as probably is the implementation of Freebsd and Linux as well, is they query the underlying device to find out what that physical sector size is. On a device that lies, it simply returns back 512 bytes. And it's not just 4K devices that have this problem. Storage vendors that export LUNs out from high-end storage devices will do the exact same thing. We've seen, for example, NetApp, known to have 4K sector sizes, and that's their block size for storing their data, but when you actually get a fiber channel LUN from them, it actually shows up and is addressable as a 512 byte device. ZFS will only be able to do what it's told. So in this case, if it reads and finds that the physical sector size is 512 bytes, that's exactly what we're going to use. When we do our allocations, as you build up files, we're going to start off with 512 byte blocks, build it up over time. So it's quite possible that you'll end up into these other two categories of problems, where we start seeing misaligned I/O, and then potentially read, modify, write conditions. I will also note that some of the AF 512 byte or 512E drives come with this special jumper. Has anybody had to deal with these drives that have this jumper on them? At least one person. So interestingly, they wanted to be able to address Windows XP. And XP by default does not align its partitions on a 4K boundary. So they came up with this idea of, well, we'll provide this little XP jumper, which, when set, offsets all the LBAs by 1. Great if you're running XP. Unfortunate if you decide to run on any other operating system that actually has a partition aligned at 4K. So if you start seeing some really bad performance, make sure you're not running this kind of mode. So first, let's talk a little bit about some of the different things that can happen in a 4K world. If you had a subblock read, in this case we're talking about, we have a device, whether it's an actual physical drive or potentially a LUN, that has now lied to us and told us that we're using 512 byte addressing. We effectively do our I/O. In this case, we're trying to read block 2. What happens underneath the covers is that physical drive will have to go off and read an entire 4K sector, and then return back the 512 bytes worth of data that we wanted. This is not really that bad of a problem. On read performance, it's negligible in the degradation that you would actually see. Where it starts to get bad is when we start doing write performance, and we start looking at having to do read, modify, writes. So here's a simple example. Again, we're just simply updating one 512 byte sector. We're using the logical sector and updating logical block 1. That results in reading the entire physical block 0 and then writing the entire physical block back out.
Is this read done within the disk or actually travels across?
This is all being done on the disk without you knowing it. And again, this all stems from that initial lie that the drive told ZFS, and now ZFS is trying to use the best allocation methodology and using 512 byte addressing, since that's what it believes the drive is capable of doing. In the end, performance issues start to crop up. Similar thing can happen even if you are dealing with 4K. So a lot of people have suggested, well, just change everything, all your record sizes, to make sure they're 4K aligned and everything will be fine. But you're not guaranteed that you're actually going to have alignment even when you're doing every I/O as 4K. Here's an instance where you actually straddle 2 blocks. So as a result, you end up having to do 2 reads to read in physical block 0 and physical block 1, even though we're only interested in 4K. We update our 4K or whatever number of blocks in our 4K block that we're writing, and then we have to do 2 physical I/Os back out of the disk. So as a result, all the various platforms and ZFS have had to come up with a way around this. And we've come up with some solutions, and I say sort of, because there are some enhancements that need to happen in this area. So the first one to kind of look at it is Freebsd. They have this utility called GNOP, I believe that's how you pronounce it. Freebsders can correct me. But it provides this kind of pseudo layer in between the physical drive and its consumers. And one of the interesting things about it is that you can actually specify the sector size that you want that device to use. And then you create this effectively pseudo device and then use that to create your pool. Pretty interesting idea because now it's totally out of the way of ZFS. You can create any device to actually deal with this problem. And one thing that's nice about it is that it handles almost every single case. If you want to create a pool, you simply create your devices ahead of time, tell them that they're 4K sectors, add them to your ZFS pool, everything's great. If you want to add devices, you can do the same thing. Some of the other implementations have those limitations. In Illumos, one of the things that we chose to do was to actually add this vendor configuration information that exists in SD.conf. It provides a way to actually specify the vendor and product information for any given drive, and then specify the physical block that it should use. So this ends up overriding whatever the SCSI driver actually discovers when it goes and probes the disks. Again, this allows you to actually do it both at pool creation time and when you actually add or attach disks. So all those devices would be represented as 4K physical devices, even though in fact they're lying to you under the covers. Where this implementation falls short is actually it doesn't allow you to do it for boot. There's still some more work that has to be done if in fact you started off with a 4K device and now want to create a root pool on it. Linux has added the A-shift property. So when you actually do pool creation, you can specify the A-shift. The A-shift is effectively the power of 2 that defines the sector size that ZFS should use. So in this case, 2 to the 12th is 4096, so 4K sectors. That's what it's going to use when it actually creates the pool, and we use that, moving forward. I don't believe that there is any work that allows you to add or devices. Is that correct, Brian?
That's right. Yeah.
So that's one limitation. One thing that we need to do as a community is try to come up with a way to kind of solve this across the board. The good news is 4K sector devices, native 4K sector devices are coming, and newer batches of AF512E devices are now telling the truth. The problem is we still have a lot of people who are suffering in this area, and there are things that need to be done. That said, there are some drawbacks. There are some things that we need to consider when using 4K sectors and ZFS. The first thing is we're going to see compression ratios actually decrease. Simply because now that data and metadata that used to be able to compress down to maybe a single 512 byte block now can only compress to 4K, or maybe can't compress at all. We have an issue with migration. Customers that are currently using 512 byte addressable devices and now need to move to 4K devices have effectively an obstacle in their way. There's no way to actually allow you to replace these devices, so people are having to create new pools and send receive. This is an area that Matt and I were discussing this morning. I think this is something that I'm going to go investigate, and maybe it becomes a hackathon project. We'll see. There's also some inefficiencies in the way that we actually do allocations. There's some metadata that we maintain within ZFS that is defined to have a 4K record size. That worked out great when we had 512 byte addressing because it would compress nicely. And we chose to use 4K simply because we knew it was metadata that was going to be added to in kind of a log-like fashion, so it was always appended to. But now that we talk about 4K sectors, we're getting no compression there. So we need to go back and revisit and see exactly what needs to be done there. More than likely, we're going to see that this simply just needs to be increased to something that's going to be more meaningful in this 4K world. We have discovered there is an accounting problem. It doesn't affect the way that your space, your actual usage space is recorded, but there is an accounting problem that does show up when using 4K sectors, and we are fixing that. So expect that to kind of come out to the community, something that we've that's recently kind of surfaced. And then RAID Z has kind of a hard choice to make. RAID Z and 4Ks really become a problem. And I'm not sure that I would recommend it, at least today, but I think as a community we need to go off and invest and understand what does it mean to be using 4K sectors in a RAID Z world. It probably works fine as long as you're doing large, records. So if you're doing 128K, you might be good. If you're doing 8K, you're probably throwing away a lot of space and doing a lot of mirroring. And as I mentioned, creating root pools. I'm not sure about grub support. I don't know if anybody has looked at 4K sectors and grub.
There have been changes pushing the grub QL for 4K sectors.
So for those on the stream, Brian mentioned that for grub 2.0, there have been some changes to support 4K. Still some things we need to investigate probably for other platforms. That's probably just only Linux is taking that on. Do you know, Brian?
I don't know who runs grub these days.
Yeah, okay. And then one other thing to consider is you actually end up with fewer Uber blocks. Normally, not something you would be concerned about. On a 512 byte addressable with 512 byte sectors, you have 128 Uber blocks. With 4K, you're down to 32. This is going to only impact if you ever need that instance of having to roll back. You're going to be limited to see how far you can actually roll back and do any kind of recovery. Questions? I am the last speaker of the day, so. Yes?
So, can you expand a little bit more on RAID Z versus 4K? What issues are there?
So the thing to keep in mind with RAID Z is, if you're going to take, let's say you have a RAID Z, you're trying to write out 12K. We'll take a 3+1 implementation of RAID Z. So we're doing RAID Z1. We have 3 data devices that we're going to implement, but we're doing a 12K write, so each one's going to get 4K. Not too bad. Now you write an 8K record. Well, I have 3 data drives. I got 8K that I'm trying to put on there. So I need to be able to I'm not getting as much efficiency because I'm not using all my entire stripe effectively. It gets more difficult when you have a much wider stripe. And now I'm having to chunk up each I/O to go across it with a limitation that at a minimum I have to use one sector, which is 4K. So you can see where if you did a 4K I/O, you end up with just a bunch of mirrors because I'm writing that same piece of data multiple times.
And that just sounds like an efficiency rather than an integrity concern.
It's something that needs to be addressed in the way that we do RAID Z. And we have the RAID Z expert up front.
I think to George's point, it's just, you're right, it's just efficiency. We're using the storage less efficiently, but like in his case, where we've got 3+1, if you do a write of 8K in that case, you'll write the 8K of data, you write 4K of parity, and then you'll need to burn a 4K sector for reasons that comments explain in the code. But so it'll just reduce to mirroring, even though you thought you had a 3+1 rating. And the problems get even worse. Let's say you've got you're using Comstar and you're creating Z-vols that have a 4K block size set on them. Well then, all of your writes have just turned to mirroring, or all of your I/O has turned to mirroring, even though you thought that you were doing RAID, and if you were doing 512 sectors, you would get some element of RAID.
It's like the more you use the RAID Z, the worse it gets. So if you have like a 12 wide RAID Z3, you're thinking this is going to be great. I'm going to get like
all this capacity,
and all this reliability. Well, it's like, well, now when I write, 8K worth of data, I'm writing two sectors of data, and then 3 sectors of parity. So it's actually, you're getting less capacity than if you were using mirroring.
And 1 sector skipped.
Right.
Yeah, and that's massive.
You're getting like a third of the actual usage.
So it's just a matter of actually going and trying to figure out what does RAID Z mean with 4K sectors so that it is efficient, especially as you start going into these really wide stripes where you're getting no benefit or penalty as a result of it. Yes?
So I just wanted to point out that the integrated platform that uses the FreeBSd makes the record type much more flexible, especially on the because now you are blocking the whole block, just right on part of it. This means that you can go with lots of record types and not suffer too much from the time block.
So Will was just pointing out that some of the work they've done on Freebsd actually mitigates a lot of the issues where you have smaller record sizes because you can go larger records when you're doing a RAID-Z straight. Yeah, that work is very exciting to us.
Why are they going to 4K?
So the main reason, so the question is why are they going to 4K? The main reason that the industry has chosen 4K, or actually larger sectors, was they effectively were running out of, it was effectively the physics behind it. They needed more, a better format efficiency on the platters. They were running out of space because you were having to create more ECC per square inch on the platter space. So in order for them to get some of that space back, they went with larger sector sizes. They were able to get back the space that is normally like the gaps and the headers that are provided between the tracks or between the sectors, and then they provided for larger space for more error correction in the future.
We need 16 terabyte disks, that's what it is.
Is that what it is? 16 terabyte disks, that's the way we're going. Yes?
A question about partition alignment. So I know that in Illumos, when you add a device to a Z pool, it creates an EFI partition and it's automatically 4K aligned. And I'm pretty sure that Linux does the same thing. When you run fdisk, it's aware of that now. Are there other platforms where you still need to watch out for default partition alignments?
From what I know, Windows tends to be if you're running Vista, Storage Pack 1, or XP, you have to be aware of partition or use the appropriate tools. Some of the hard drive vendors, like Western Digital, actually ship these alignment tools for you that you can either download from their website or they ship them with the disk, so that when you install this, it properly aligns the partition that you're going to use on that disk. Yes.
So is that like a tool to tell Windows how to align it?
Yes.
Because you could also imagine a tool which does that jumper thing by telling the device hey, by the way, do everything offset,
Yeah, absolutely.
So WD has that. They have a thing where you set the drive into a mode where it offsets it by that, or they have a jumper, I think is what it is. I don't know if that's so common anymore. Everything you is 1 meg aligned partitions now, particularly in most cases.
Yeah, I found it interesting, I think it's Dell's website or something has a link specifically dedicated to 4K sector devices. How can I tell if I'm using 4K? And what does that mean to me? And it's interesting, all the hard drive vendors kind of have their own little white paper tagline of preparing for 4K. It really was kind of this disaster that they were trying to avert.
What's more interesting is that not all that information really lines up.
That's true. Yeah. Yes?
George, can you mention briefly your work timing out ZFS I/O to disk?
So the question is, can I mention briefly the work about timing out IOs to ZFS? Yeah, so there's, actually you saw in kind of Brendan's talk, there was a slide where he showed the PERC ECC errors, I believe, and you would see a case where IOStat shows 0 IOs going to the device, but it's 100% busy. We've seen similar things at Delphix, primarily with a variety of LSI controllers. From what we know of the problem is, it does tend to be a failing drive or an ECC error or something of that nature. But when you actually dig into it, what you're finding is that the IOs have been issued from ZFS, they've been transferred to the controller, and then they just never return. So ZFS has long had a policy of not having timeouts. It relies on kind of the underlying controllers to really make the decision. And Brendan even mentions if only the drive would tell me that it was failing or give me an error of any kind, then from ZFS's perspective, we could actually do something about it. What I've implemented is what I'm referring to as the SPA dead man timer. And this is effectively just a workaround to deal with these types of issues until we can actually get root cause or potentially new firmware or controller fixes or whatever. But the idea behind it is that when we actually start syncing out transactions, every single time that we actually flush to disk, we'll kick off a timer. And the current default value is 1,000 TXG units, where the default value right now is 1 second per TXG. So 1,000 seconds. If I/O, first of all, if this processing doesn't complete in 1,000 seconds, then it starts querying every single device associated with that pool to determine, is I/O happening to that disk? What we're trying to avoid is we just have a very slow pool and things are trickling through. In most cases, what it finds is that it may, let's take a pool with 4 disks, as it queries those 4 disks, it may find one that actually completed I/O recently and then comes across one that hasn't completed in that 1,000 TXG unit time. And if that's the case, then it panics the box and then gets you out of the condition. There's been some controversy about the fact that we panic the box, but the reality is once you're in this condition, there is no way out of it. You are in a reboot kind of situation. The drive never recovers gracefully. The controller never comes back. In many cases, you may not even know you've had this problem because if you didn't detect it early enough, you might get into a situation where the entire machine is hung. You can't even log in. So you come in, you're like, my machine's wedged, I have no idea what happened. At least this way, if you get a panic, you can have somebody look at it after the fact and go, yes, in fact, you had a drive that went out to lunch and that's why. So we kind of took a drastic approach. It is currently on its way into the Illumos code base. It can be turned off, so, but be aware of it. It's called the spot dead man or I/O dead man timer. It is something that's coming to the Illumos gate.
That's going to be off by default, right?
It's actually on, but it's on for x86 platforms unless you're in a virtual world. Off on Spark. We have only seen this in x86, and again, primarily with LSI-based drivers.
The hardware rate ones or the HBAs?
Both.
Yeah.
Nice.
It's the same hardware. Unfortunately, yeah. We're seeing that at Accenture too. We're trying to get SD to do a little more work there. Unfortunately, the people working on it aren't here today.
Yeah, you know, again, this is we see this kind of as a stopgap until we can figure out exactly what the real problem is. And once we know what the real problem is, then we can rip much of this, you know, most of this code back out. But we've seen this as a big problem, and I know several of the companies and vendors that have been here have talked about various issues that they've seen with drives just going out to lunch. At least this way we can get our customers past it, however harshly it might be, and potentially get some debugging information at the same time. Yes?
Do database tables on top of ZFS compound the issues you're describing?
Do database tables on top of ZFS compound the issues with regards to 4K, you mean? Yes, in some ways, yes, because we're dealing with just an 8K record size. But the reality is when you're on a device that is lying to you, it doesn't really matter what you're writing. What will compound this is, you know, you enable compression, for example. You could be on a nice 4K sector that compressed down and now all of a sudden, or an 8K sector that compressed down some weird alignment causes you to get into these situations. I'm being told beer is ready.
Hang on one second. There is one question on the screen which I hope you can answer quickly, if at all. Is there a document for ZFS best practices with 4K for RAID Z, RAID Z2, and RAID Z3?
A document, there is actually on, I want to say it's on the Open Indiana wiki. There is a document that describes a lot about using advanced format drives and how to configure it. I don't know about other platforms. There isn't anything today that describes 4K and RAID Z issues. Definitely something that we need to start talking about right now.
Okay, I think we're done. Thank everybody.